Well, let's first take a look into what is lambda expressions and what is the main use of lambda expressions in Java. Well, lambda expressions were introduced in Java 8 and lambda expressions facilitates a functional programming in Java. Well, what is lambda expressions? Well, lambda expression is a anonymous function. It means it is a function without name and does not belong to any class or object. And the main use of lambda expression is to implement functional interfaces. Well, before deep dive into lambda expressions, first let's quickly take a look into functional interfaces, because we are going to use lambda expression to implement functional interfaces, right? That's why you first need to understand what is functional interfaces. Then only you can able to understand more about lambda expressions. Alright, so lambda expression is basically used to implement functional interfaces. So let's quickly take a look into what is functional interfaces first, and then we'll come back to lambda expressions. Well, functional interfaces were introduced in Java 8. An interface that contains exactly one abstract method is known as functional interface. Alright, so functional interface is an interface that contains exactly one abstract method. For instance, look at here the code snippet. My functional interface is an interface and it contains exactly one method, that is execute method. And as we know that whenever we define a method in an interface, by default it is abstract, right? And we no need to mention abstract keyword in a method. Alright, so just remember, functional interface is an interface that contains exactly one abstract method. Abstract method means a method we don't have any implementation. Okay, so in order to provide implementation for this method, you have to create a class and then you need to implement this interface, and then you need to override this method, and then you need to provide the implementation for this method. Well, functional interface can have any number of default static methods but can contain only one abstract method. For example, consider the code snippet over here. My functional interface is a functional interface. It contains default and static methods which has the implementation, and it can contain only one abstract method, that is execute method. So functional interface is an interface. It contains only one abstract method, but it can contain any number of default or static methods. So now we understood that functional interface is an interface. It contains only one abstract method and it can contain any number of default and static methods. Now let's go back to our lambda expression and then we'll deep dive into the lambda expressions. Well, sometime a beginners may confuse with the lambda expression and methods. So let's go ahead and let's see the difference between lambda expression and method. Alright, so that you can able to understand a lambda expression better. Well, method is always belongs to class or object in Java, whereas lambda does not belongs to any class or object. Okay, so whenever you create a method in Java, you should have to create that method in a class, right? But lambda does not belong to any class or object. It should be isolation to the class or object. Okay, and you can able to see method has these parts, like method has a name, parameter list, body, and return type. For example, look at here the addition method over here. Addition is the method name, int is the return type, int a comma int b is the parameter list, and return a plus b is the method body. So this is how we create a method in Java, and these are different parts of the method. Okay, now let's see how lambda expression looks like and different parts of the lambda expression. Well, lambda expression has no name. It means lambda expression is an anonymous function, right? So we no need to have to provide a name to the lambda expression. Lambda expression has a parameter list. Lambda expression has a body. Okay, and no need to mention the return type. Well, you don't need to mention the return type in the lambda expression because Java 8 plus compiler is infer the return type by checking the code. Alright, so in lambda expression we don't have to mention the return type because Java 8 compiler is smart enough to identify the return type of the expression. Okay, we'll see an example how Java compiler can identify the return type. Okay, so if you can see the code snippet over here, so this is how the lambda expression looks like. Alright, so this is the parameter list of the lambda expression, and this is the arrow. It will basically link the parameter list with the body, and this is basically a lambda expression body. Lambda expression body can contain a single statement or multiple statements. Alright, we'll understand more about lambda expression in a example section. Now let's take a look into lambda expression syntax. Well, lambda expression basically contains these three parts. First part is lambda input parameters. Second part is arrow. So this will denoting lambda. Third part is lambda body. Okay, just remember this syntax because whenever we write the lambda expression, we use this syntax. Okay, so first part is lambda input parameters. Second part is arrow. Third part is lambda body. Alright, now we pretty much understood overview of lambda expression. Now let's go ahead and let's deep dive into lambda expressions by creating the examples. Well, let's open the IntelliJ IDEA and let's go to new project option over here and go ahead and click on it. And then here choose Java and then choose project SDK. So whatever the JDK you have installed in your machine, that you can go ahead and select from here. So I have installed Java JDK 16, so I'm going to choose 16 over here and then click on next, and here you need to provide the project name. So I'm going to provide project name something like Java Lambda expressions, and you need to choose the project location over here. In my case, I'm going to locate this project in a downloads folder. So go ahead and click on finish. Alright, and let's go and let's create one simple package. So go to src folder, right click new and then choose package. Let's go package name something like com.java.lambda, hit enter, and within this package let's create a class and let's name it as something like lambda example. Okay, great. Now let's go and let's first see how to write a code using traditional way, and then later we'll convert the traditional way into functional programming using lambda expression. Okay, first we'll write a code using traditional way. Well, let's go and let's create a SAP interface and let's provide a few implementations for SAP interface. Well, here I'm going to create an interface called SAP. Alright, well, within a SAP interface, let's define a method called draw. So we're going to basically draw a SAP. Okay, and whenever we define a method in an interface, by default it is public and abstract, right? So we don't have to again add a public abstract keyword to this method. Alright, now let's go and let's create a few implementations for this interface. So let's first have a rectangular implementation. Okay, let's create a class rectangular which implements SAP interface, and just go ahead and mouse over on this rectangle and you can see implement method. So just go ahead and click on it and choose draw method here and then click on OK. Alright, now we have overridden draw method within this rectangle class. Let's go and let's provide implementation for this draw method. So to keep it simple, I am going to just provide one sysout over here, and then I am going to write a statement something like rectangle class draw method, something like this. Now we have created a rectangular implementation for SAP interface. Similarly, let's go and let's implement square and circle. Okay, so just create a class, let's name it as a square which implements SAP. Alright, and just mouse over on this square class and click on implement methods, click on draw, click on OK, and just put one sysout and let's call it as square class draw method. Alright, and similarly let's create one more class implementation that is for circle. Now implements SAP interface, and let's override this method and provide the implementation. Okay, pretty simple. Now what we have done, basically we have created rectangle, square, circle. So these are the classes which implements SAP interface. Okay, so this is how we write the code in a traditional way, and this is basically a polymorphism. Okay, method overriding. So basically we are overridden the method and we have provided the implementation in a class. Okay, so this is basically a polymorphism OOPS concept. Okay, now let's see how we can use a lambda expression to convert this object oriented polymorphism concept into functional programming. Okay, so basically we have written a lot of code over here. Okay, and we can use a lambda expression to reduce a lot of code. Well, you can closely observe this interface, that is SAP interface. So this is basically a functional interface because it contains only one abstract method, right? And we have provided a classes which implements this interface. So now what we can do is we can replace all these class implementations with the lambda expression. Okay, so I'm going to basically show you how we can use a lambda expression to reduce a lot of boilerplate code over here. Okay, we basically convert this object oriented program into functional functional program using lambda expression. Okay, it's pretty simple guys, just follow the steps that I'm going to show here right away. So first what we're going to do is we're going to copy this method and we convert this method into lambda expression. Okay, so I'm going to show you my personal tip how I convert methods into lambda expression. Okay, just copy this method and go to this public class over here and then simply create a main method, and within main method simply paste this method. Well, one more very important point is lambda expression can be assigned as a value to the reference variable. For example, in Java we basically create a variable like this, right? For example, string str equal to hello. Okay, so this is how we basically assign a string value to the variable of type string. Well, basically we need to assign a lambda expression as a value to the reference variable, and we have to use a reference variable of type functional interface. In our case, SAP is a functional interface, right? So let's go ahead and let's have a SAP reference variable here, and let's call it as a rectangle. Okay, and get rid of this at override annotation. All right, now we haven't completed our lambda expression yet. We need to remove some parts from this code. Well, here public does not make sense in a lambda expression, so we have to remove this public because public makes sense in case of method and variables in a class, but lambda expression is not belong to any class or object. So get rid of this public from here. And as we know that lambda expression is an anonymous function, it don't have any name, so get rid of this name. Okay, and yeah, well, you can see the return type void over here. Well, we can also get rid of this void return type from here because Java 8 plus compiler will automatically infer the return type of the code. For example, what Java compiler does, like it will look into this abstract method and it will look into the return type of this abstract method basically, and the return type is void, right? So by looking into the return type of the abstract method here, Java compiler will infer the return type of this lambda expression, right? So we don't need to again mention the return type over here. All right, so let's get rid of this return type from over here. Now in order to complete this lambda expression, we need to put a lambda symbol between this open and close parenthesis and this open and close curly braces. So let me put a lambda symbol, that is arrow symbol. So arrow symbol basically link this parameter list into method body, and in case of lambda expression you need to put a semicolon at the end of this lambda expression. Okay, now this is your lambda expression. It's pretty simple, right? Again, you can make this simpler. For example, let's say in a lambda expression body, if you have only one statement, then you can also get rid of this open and close curly braces. Okay, so let me remove this, and if you can see here, now the lambda expression looks neat and cleaner, right? So this is how basically we write the lambda expression to implement a functional interface. So basically what we have done, we have assigned this lambda expression as a value to the reference variable of type SAP. So SAP is a functional interface. Now what we're going to do is we're going to call a draw method by using this reference variable. So simply call draw method over here. Okay, pretty simple. Now let's run the program and let's see how this code works. Well, if you can see here, rectangle class draw method, it means that the lambda expression that we have written to implement SAP functional interface is working as expected. Alright, so this is how basically we write the lambda expression to implement a functional interface. Well, if you look at the code of rectangle class implementation, we need to write a lot of code, right? And if you look at the again lambda expression, in 2 lines of code, we have done the job of this much of code. Okay, so this is the traditional way how we write the code to implement the interface and override the method and provide the implementation, right? So now what we have done, basically we have converted this object oriented programming into a functional programming using Lambda expression. All right, so in order to have a hands-on experience, let's write the Lambda expression for square and circle as well. So before that, let me remove this code. Okay, now let's write the Lambda expression for square and circle to reduce the boilerplate code. Well, simply copy this draw method from square class and go to main method. Within a main method, paste it over here and just get rid of this annotation. All right, and just assign this block of code to the reference variable of type shape. Shape is here a functional interface. Let's say the reference variable name something like square, and this should be a typo here. All right, now let's remove the unnecessary parts. Well, public does not make sense here, so just remove public. And also the Lambda expression is an anonymous function. It means Lambda expression don't have name, so get rid of this draw name here. And also we can remove the return type, because Java 8 compiler will automatically infer the return type by looking into the code. So get rid of the return type as well. All right, and let's put a symbol arrow here. All right, and let's also put the semicolon to complete this Lambda expression. Okay, now this becomes our Lambda expression. And if you can observe this Lambda expression over here, this Lambda expression body contains only one statement. We can also remove this open and close curly braces. Okay, let me get rid of this open and close curly braces from over here, and then we can simply call square dot draw method over here. That's it, pretty simple. Now let me run the program and let's see how it works. And there we go, it is working as expected, isn't it? Now let's go and let's write the Lambda expression for circle implementation. Okay, so as usual, just copy this method, go to main method and paste it over here, get rid of this annotation, and then let's assign this block of code to the functional interface and let's call it as circle. Okay, and let's remove the unnecessary parts. Public is not required, name is not required, return type is not required. All right, and just put the arrow symbol and put the semicolon at the end of this Lambda expression. And this Lambda expression body contains only one statement, so get rid of this open and close curly braces as well. Perfect. Now circle dot draw. Okay, let's run the program and let's see how this works. And there we go, it is working as expected, right? So this is my personal tip how I convert basically a method into Lambda expression. So I hope you found this technique useful. Now let's go and let's see how to pass a Lambda expression as a method parameter. Well, in order to demonstrate that, I am going to create a method over here. Let's say private static void, and let's give method name as a print and just pass a method parameter of type shape here. All right, and then simply call shape dot draw method. Okay, now let's go and let's use this print method and let's pass a Lambda expression as a method parameter. We'll go to the main method here and go at the bottom, and here simply call print method. And if you can see here, print method expect a implementation of shape interface, right? And here we have used Lambda expression to implement shape interface. So just go ahead and pass one of the Lambda expression here. So here I am going to pass a rectangular. Okay, so this is how basically we pass a Lambda expression to the method. Okay, if you can see here, we have stored this Lambda expression in a variable of type functional interface, that is shape, and we are passing this variable as a method parameter here. Okay, and we can simply comment out this rectangle dot draw method, because this call we have made within this method, right? Similarly, simply call print method and then pass square. So this is how we pass a Lambda expression to the method, and we can simply comment out this code. And similarly, let's pass a circle lambda expression and simply comment out this code. Now let's run the program and let's see how this works. And there we go, it is working as expected. Alright, so this is how basically we pass a lambda expression to the method. And if you can see here, we can directly pass this lambda expression here, for example like this. Okay, instead of assigning a lambda expression to a variable, we can directly pass a lambda expression to the method, something like this. Similarly, let's do it for square and circle. Let me copy this and paste it here, and let's get rid of this code here. Alright, this looks good, right? So this is how basically we pass a lambda expression as a method parameter. Okay, so basically here we are passing a behavior to the method. Okay, we are passing lambda expression as a behavior to the method. Okay, this is called basically a functional programming. Okay, so these are the very important things you have to know in order to write the functional programming in Java. Now let's go and let's write one more lambda expression example to see how we can pass the parameters to the lambda expression. Alright, great. Go to the package and right click, new and choose Java class, and here let's give class name as lambda parameter, something like this. And let's create one functional interface, let's say addable. Alright, and just create one method, let's say addition int a comma int b. Okay, so this is nothing but a abstract method. Alright, perfect. Well, first we're going to see how we can use a traditional way to implement this functional interface, and then we'll convert a traditional way into functional programming using lambda expression. Alright, just create a class and let's say addable impl is a class name. It implements addable interface. Now let's go ahead and let's override this addition method in this class, and let's provide the implementation for this addition method. Well, if we can mouse over on this class, you will get an option to implement the method. So go ahead and click on implement methods over here and choose addition, and then click on OK. And here basically we are going to add these two numbers, right? So just write the logic here, that is a plus b. Okay, pretty simple. Now we have created a class which implements this functional interface, and we have basically overridden this method and provided the implementation for this method. Well, this is how we write the code using traditional way. Now let's go and let's see how we can convert this traditional way into functional programming using lambda expression. So go to lambda parameters class. Within this class, let's have a main method over here. Okay, and in order to convert this method into lambda expression, simply copy this method and paste it within a main method and get rid of this annotation, and then simply assign this block of code to the functional interface. Okay, and let's call it as addition, and let's remove the unnecessary parts. Public is not required and method name is not required because a lambda expression is an anonymous function, it don't have name, so get rid of this addition name. And also this int return type is not required because Java compiler will automatically infer the return type by looking into the return type of the abstract method. So in this case the return type is int, so compiler will automatically recognize that the return type should be int, so get rid of this return type from here. Alright, and now let's put arrow symbol and also put the semicolon at the end of this lambda expression. So this becomes our lambda expression. Okay, now let's go and let's also simplify this lambda expression even more. Well, if you can see the lambda expression body over here, it contains only one statement, so also get rid of this open and close curly braces. Well, let me remove this, and if you can see here, if the lambda expression body contains only one statement, so we can also get rid of this return keyword from here. Okay, now this lambda expression becomes a neat and concise, right? Now let's go ahead and let's call the method here, that is addition method, and just pass 10, 20. Perfect. Well, if you can closely observe this lambda expression over here, we are using a parameter list, that is int a comma int b. So this is how basically we pass the parameters in a lambda expression. Okay, and these parameters we are using in the lambda expression body, and this arrow symbol basically link the parameter list to the body of the lambda expression. Okay, so this is the best example to see how to write a lambda expression using parameter list. Okay, and if you can see the type in a parameter list, for example, a is a variable, it has a type int, b is a variable, it has a type int. So we can also remove this type here. Okay, for example, if I remove this, then Java compiler will basically automatically infer the type of these parameters. Okay, we don't have to again mention the type for these parameters, because Java compiler is smart enough to identify the type of these parameters by looking into the method parameters. For example, addable functional interface has an addition method, right? And this addition method we are implementing here by using lambda expression, and Java compiler will basically look into the type of these variables here. So a has a type int, b has a type int, right? So Java compiler will basically look into this type of the parameters. All right, so that's why we can also remove the type from here. Okay, so I hope you understood. Now let's go and let's print the result of this method. So here what I will do, I will say int result equal to, and then I will put this out here and then simply print the result. Okay, now let's go and let's run the program and let's see how this works. And there we go, addition of 10 plus 20 is 30, right? So this is how basically you write the lambda expression which has a parameters. Okay, now let's see how to write a lambda expression. It contains a multiple statements. All right, we'll take this example itself. So here what I'm going to do is I'm going to just comment out this code over here, and I'm going to rewrite the lambda expression for this method. So I'm going to copy here, paste it, and get rid of this annotation, and just assign this block of code to the functional interface. All right, and just get rid of these unnecessary parts, and put arrow mark here, and put the semicolon at the end of this lambda expression. Okay, now what we're gonna do is we're gonna write the multiple statements here. So basically here what I will do, I will say int c equal to a plus b. All right, and then I will simply return c. Okay, so this is how basically we write the multiple statements in a lambda body. Okay, now if you can see, lambda body contains 2 statements. Now let's go and let's create one more lambda expression example to implement runnable interface. Well, runnable interface is basically a functional interface, and we can use a lambda expression to implement a runnable interface. Well, go to the package, right click on the package, new, and then choose Java class, and let's give class name as something like runnable lambda example, and hit enter. Now first we'll see how to write a code using traditional way, and then later we'll see how to write the same code using lambda expression. So here we'll create a class which implements runnable interface. Let's say thread demo class which implements a runnable interface, and then simply override the run method over here. Just mouse over, click on implement methods, choose run method, and there we go. And to keep it simple, within the run method we'll put a sysout and just print run method called something like this. Okay, now go to the runnable lambda example class and then create a main method, and within a main method we are going to create an instance of thread class. So let's create object of thread here, and then pass object of thread demo. Okay, and then simply start the thread here. Okay, so this is how traditionally we create a thread object. Okay, we create a class, implements runnable interface, and then we override the run method, and we provide the implementation for run method, and we create a thread instance here, and we pass the object of thread demo class, and then we start the thread. Okay, so this is how we create the thread using traditional way. Now let's go and let's see how to use a Lambda expression to implement a runnable interface, and then we'll create a thread object. Okay, well, if we can go inside runnable interface source code, you can able to see runnable is a functional interface, because runnable contains only one abstract method, that is run method. And if you can see, runnable interface is annotated with add functional interface annotation. It means runnable is a functional interface, and we can use a Lambda expression to implement a runnable interface. Alright, so let's go back to our class, and here we're going to use a Lambda expression to implement a runnable interface. Let's use a runnable functional interface reference variable to assign the Lambda expression. So this is the syntax of the Lambda expression, right? And simply put on sysout within a Lambda expression body, and just call it as run method called using Lambda, something like this. Alright, and then we need to create instance of thread over here. Thread, let's say Lambda equal to new thread, and then pass runnable, and then simply start the thread. Perfect. So this is how basically we implement a runnable functional interface using Lambda expression, and then we create a thread object, and then we pass a Lambda expression implementation as a parameter to this constructor, and then we start the thread. Okay, so let me run the program and let me show you, and there we go. So this is working as expected. Well, we can simplify this Lambda expression even more. If you can see here, Lambda expression body contains only one statement, so we can get rid of this open and close curly braces over here. Alright, perfect. And if you can see here, we can simply pass this Lambda expression itself as a parameter to the constructor. For instance, I'm going to pass here, and I'm going to get rid of this statement. Okay, so this is how we can pass a Lambda expression as a parameter to the constructor as well. If I run the program, it should work, and there we go. Alright, so this is how basically we use a Lambda expression to implement a runnable interface, and we pass that Lambda expression to the thread object, and then we start the thread. Alright, I hope you understood how to use a Lambda expression to implement a runnable interface, and how to create a thread, and how to pass a Lambda expression. Alright, great. Alright guys, I hope you pretty much understood how to create a Lambda expressions in a Java. Alright, I will see you in the next lecture.